So in this video we begin discussing what statistics is, and the definition I want to use throughout the class is that what we learn in statistics is how to convert data, which is plentiful, into information, and information is collapsed data, and it has some type of intelligence included so that we can use that to make decisions. So information science is about taking data, turning it into useful information, into patterns or something that people can recognize. And we want to do that with statistics, is take data, which is unstructured, all over the place, collapse it into information, and we use that to make decisions. The challenge is that there are plenty of different types of data, a lot of different types of decisions we want to make. So this can get fairly large in terms of the different techniques we need to use to collapse data into information. And as just a quick example of two different types of data structures, let's look at this spreadsheet. This spreadsheet will be available to you, and it will contain all of the lecture data, so you'll be able to access and reference this. So this particular worksheet is called Credit Card Transactions and NFL 1976 Data. And that's all it is. This is transactional credit card transactions by time slice. I can tell you it happened on March 6th on a certain day, the time of the day, what part of the United States where the transaction originated, the type of credit card they use, some demographic data where we've categorized this is a woman, and she has already been classified as someone who purchases from us frequently. So they're a high category as opposed to some are medium, some are low. This particular transaction, 4 things were purchased. The total cost was $136, and the single most expensive item cost about $80. And we have this data for 400 or so records. And it is data. There's no information in this. We can't look at this and say which day of the week do we spend the most money, what is the average purchase price, what is the maximum number of items ordered in any transaction. All of this would be information that we need to be able to gather maybe for us to make decisions, but right now it's not information, it's just data. Similar, this is for you sports people. This is data from the 1976 NFL season. So this is the Washington Redskins, Minnesota Vikings, New England Patriots. And what we have are some statistics, some data, I guess is what I should say. We know that the Washington Redskins won 10 games that year. And this is how many yards they gained rushing and throwing the ball. This is how well their special teams did. This is their average punt yards and average field goal percentage. Did they turn the ball over or not? This is given. How do they cheat? So this is penalty yards. I think Oakland Raiders will be high. Sure enough, it's a high one, and they're Oakland Raiders. And then their defense against how their defense did against the run and the pass. So a bunch of data. What does it mean for us? How do we translate these statistics? And can we build some relationship between these statistics and if they were a good team or not in terms of wins? Two different types of ways to think of statistics. There's descriptive stats and inferential stats. We'll start out with descriptive stats, and that's just really building graphs and calculating summary stats like a sample average or a sample range or a percentile. The act of doing that, of turning a bunch of numbers into a single number or turning a bunch of numbers into a graph, that's descriptive stats. And those are great. We'll go through that. But also, there's going to be questions that we're going to have. And if we have a question, we may have a hypothesis that we think is something is going to happen. And we want to set about to be able to prove or not or disprove a certain hypothesis. For example, we might have a question, who's going to win the presidential election? And we may have a hypothesis of something, and we try to set about in proving that or not. Now, obviously, this would be we would do this before the election occurred, and we were trying to predict who would win. And so we don't have complete data, complete information. We're going to take a sample and be able to infer something about the ultimate decision or the population. Another way to think of this is with this picture, and there's this big cloud, and what I mean, but it's not really a cloud. It's supposed to represent a population that is large, and we don't have time to measure everything in the population. Either we don't have time, or we don't have the resources, or it's just too big and we can't count everything in that. And there's certainly things about the population that we don't know about. There might be population parameters, like what the population mean is, or the population standard deviation, which is signified by the Greek sigma. We may want to know what the underlying shape is. What does that look like? That could be good information for us. And we don't know what that is because we can't measure everything. So what do we do? If we cannot do a census, if we cannot measure everything, what should we do? Well, we'll take a subset of that. We'll take a sample. And hopefully we're not taking a sample that's biased, maybe just from one part of that population, but we do our best to build a sample that is representative of the population. And one way to remove bias is to do a random sample. It's the equivalent of closing your eyes and pulling a number out of a hat. We want to be able to do something so we're not creating unfairness because of our technique when we create our sample. But from the sample, we can calculate some statistics. We can collapse this sample and calculate a sample average, a sample standard deviation. And that by itself, would you call descriptive stats. That line that separates descriptive stats from inferential stats is that the act of collecting data and calculating summary stats and building graphs, descriptive stats. But we can continue, and there's plenty of questions that we might have. We may want to see the change in a population parameter over time. Are this year's students any different than last year's? Is this particular marketing strategy, did it work differently than another marketing strategy? There's questions that we can have, and so to answer those questions, we've got to always start with some assumptions based on the type of data we got, type of tests that we need. We'll talk about that more. And we develop a hypothesis, and from that hypothesis, we can run a statistical test. And the test will always have a conclusion. And then from the conclusion, we can infer something about the population. So inferential stats is taking that data and being able to run it through a statistical test, and then based on the test results, infer something about the population. And we'll stop there and we'll start another video as we start looking at descriptive stats. Thanks.